Hey, all of you mini players, you gamers, terrain builders, railroad enthusiasts, folks out there that are making cool things, dealing with another random making encounter. And if you are returning to the channel, thanks for coming back. If you're new to the channel, hope you find this interesting. I've been on a bit of an electronics kick. I've been building a lot of things that are requiring LED lighting, and this project comes courtesy of a subscriber, Gene. Gene, you know who you are. Thank you for asking about this. Gene said, hey, I need a better way to control LED lighting and create a thunder and lightning effect. I'm building my railroad table. I need to really up what I've got going here and really make it believable. What do you think? I've got some ideas. We kicked some emails around, and this is kind of what I came up with, a pile of parts. So let's talk really quickly about what is in the pile of parts, and then we will talk about how we put it all together and make it actually work. So for this project, we're going to be using an Arduino Nano. This is an Elegoo Arduino Nano. It's a good price. You get, you know, a few for the price of one. So I'm using this Elegoo Nano. This is an MP3 player, a mini MP3 player. This is a DfPlayer. We're going to be sticking it all on a Perma-Proto board here with some little screw terminals for speaker connections and power. Little couple pin headers to attach basically the connections to the LED strip. A bunch of jumpers I made. These are just going to be soldered straight into place just to keep everything nice and tidy. I need 3 resistors. 2 are going to be for a voltage divider connecting the logic or the transmit or receive connection on the DfPlayer to the Arduino. And then 1 is to be the resistor that helps with data spikes on the NeoPixel, big old smoothing capacitor so we don't blow some NeoPixels or anything else, and some speakers. Now, basically, you could run external powered speakers. We're going to see what happens with these little speakers, but we'll look at just if we can make all of this come together so that the theory here is we will create an audio track or tracks, and we will have some sound and then some light, or a flash of light and a sound. Now, you might be saying, I don't need thunder and lightning. However, you could be building a battle diorama and you need an explosion and a flash. And so this is a way to tie light and sound together. So without any more talking, what I'm going to do is I'm going to go over to the solder station. I'm going to solder all of this up. I'm not going to bore you with the messy details of soldering to the board. I'm going to come back. I'll explain the connections, and then we'll look at the code that might drive this and see if we can make this whole thing work. So back in a jiffy. So let's take a look at the connections. I'll post a schematic or a diagram so that you can pause on that and take a look at it. But we'll talk about this from in to outputs. And so let's just jump into that really quick like. So we've got our power in, and this is running off of a 5 volt, 1.5 amp wall transformer. If you are going to run a lot of NeoPixels, you may want to up that amperage a little bit. This is a 5 volt system, basically, but you do need to look at the amperage for the amount of NeoPixels that you're running. So if you're running a big long strand of them, you want to make sure that your wall transformer is going to handle the draw, because these are actually running briefly, but they're at full intensity in some cases, and so we're flashing a lot of LEDs at their full brightness, and you're going to have a lot of you're going to draw a lot of current there for brief periods of time. So Coming into that, we've got a very large capacitor. This is a smoothing capacitor, and it is there for the benefit of the NeoPixels so that we don't have a big surge of energy when we power on and we blow a pixel. They are, again, running directly off of the power strip. Now, for those of you who don't know what this is, if you're not familiar with breadboards, this is basically a breadboard, but this is a Perma-Proto board. This is from Adafruit, and it's basically a breadboard that you can solder to. So it's configured exactly like a normal breadboard with 2 power strips or 2 power buses on either side. So these are all connected vertically, positive and negative, voltage and ground, and there's one on either side. There also then there's a gap. And then there are horizontal rows that are connected, and those horizontal rows are connected, and those are in rows 1 through 30 with a gap in the middle to allow us to connect things like microcontrollers and our mini players. So when you see things coming down in the middle vertically, they are not connected, they're not bridging anything. They are connected horizontally, and then as they bridge across the middle, there's a gap there, so they're not connected that way. They're sort of insulated that way. So if you start to work with these, it all becomes more apparent. Okay, so power. To power the Elegoo Nano, there is a power voltage in and a ground that are the red and black wires, and those are just little jumpers I made using just solid core wire and some strippers, and they just are a nice tidy little way to jump the power right into the Nano. The Nanos are all soldered in, as is the DfPlayer. In a perfect world or in a better world, you might consider maybe removable headers or sockets that you can actually push these in and pop them out. But this was something that I wanted to be pretty permanent, so I just soldered them straight on in. The DfPlayer is a 5-volt tolerant for its voltage, and so I've got a little jumper coming into this top pin here in the corner that's the voltage in. And then the ground is on the opposite side, thank you DfPlayer Mini people, and that is right on this second pin in, and that actually jumps to the ground strip on this side, and then I bring the ground back over with this much longer jumper. Okay, so that's what that is. Little weird and kludgy, but clean, and it works, and it's visible, and it's easy to understand. Okay. Now, that's power. So by connecting those 4 wires, I have now powered both boards and we're good to go. The next thing is outputs. So the power out, the output to the NeoPixels is controlled by this data line that controls it. So we'll talk about that in a minute. But that's why this is sort of sitting inside on one of these inner lines, and that's going to be driving the data into the NeoPixels. The audio out is actually here on this side of the board, and it's the first 5 pins starting 1, 2, 3, 4, 5. The first 3 are to the amplifier, and they're designed to run external speakers, a unpowered external speaker up to 3 watts and 4 ohms. There is a way you'll see that they say that you can actually run 2 speakers in stereo using the center pin as a common ground and using the first and third pin, or basically if we counted them, skipping a pin as the left and right channel. The next 2 pins are your left and right channels for headphone and or amp out. So it's a lower signal, not a big old, driving as much power as you can to your speaker kind of thing. And it's intended for headphones and or an external powered speaker, amplifier. And so there's left and right, and then it goes to the common ground. So that's what these 3 wires do. Now, I didn't have a really slick, elegant stereo female plug that I could create a nice, elegant, cool plug for this, but I did have a perf board friendly version, so I kludged together this this little dongle. I didn't have room on the perf board to actually solder it into the perf board. So a lot of ways we could maybe make this a little bit cleaner, but hey, it's solid, it works, it's clean, it's tidy, and it works like a charm. And now you can plug this into external speakers like a computer speaker, crank that up, get a bass going, just really drive the bass going, rumble the whole house, and get the full thunder and lightning effect. So out in the grand scheme of things, unless you're trying to build something really tight, compact, and need to have a very small external speaker that you can hide or put somewhere, which is where this would come in super handy, I would actually just use the dongle and or the headphone output and run it off of external powered speakers. You're going to get a ton more volume that way. Okay, that's the audio out portion of the story. Now we need to control the mini player, and so to do that we've got to transmit and receive coming off of 2 pins on the Nano. So we have D2 is coming off of the D2 pin, the digital 2 pin, and it actually runs through this little voltage divider, and it comes into, I want to say, the receiving side of the player. That seems to make the most sense. So I'm transmitting my serial commands off of the player through a voltage divider into the player. And the reason it's going through a voltage divider is because even though I can power this off of 5 volts, turns out its serial connections do not like 5 volts from what I've read. And that's a little bit of over voltage for them. And so there are some schematics you'll see out there that put a resistor between them, and that's it. Resistor doesn't do jack in that respect. It reduces the amperage, it reduces the current, but it does not drop the voltage. So it does. So if it may make it maybe a little bit friendlier, but realistically, if you're trying to get to 2.5 or something under 5 volts, under 3 volts, you need it to drop a voltage divider in. So basically it comes off of the pin through a resistor. These resistors are soldered in series, so they're continuous, and it drops this resistor to the ground, the main ground, and then between the two, where we get our voltage dividing, is the line that comes into the receiving end of the player. Now coming off of the player, it transmits back to D3 on the Nano, and it does not need any voltage divider because this is lower voltage transmitting back to higher tolerance voltage on the D3 pin. Hopefully that makes all sense. That was kind of a mouthful. The bottom line is, from what I was reading, if you want to be kind to your DfPlayer Mini, this voltage divider is kind of a nice and important thing to have. Okay, the last pin that we're using on the Nano is D4. That comes down just on a little jumper here to this section. It goes through another resistor. I want to say this is a 470 ohm resistor. It protects the data line on the NeoPixels from burning out the first pixel, from spikes, you know, basically a current spike. And this is where it does do its job of reducing current from a current spike that might damage the first pixel. So it can handle the voltage, but it really doesn't like a lot of current hitting it all at once. So we throw a little resistor in there to help with that. So those are the connections. Now let's talk about the logic behind the programming. First and foremost, none of this happens in a vacuum. I looked at a bunch of different examples and brought together a couple different code bases that I had found online. So, you know, shout out and comments in the code to the folks who contributed those, who were the giants that whose shoulders I stood on to get here. But the basic logic is this. The two things that we're really controlling, or three things we're controlling, is the volume of the lightning. And so the volume there is the same on the audio tracks, but is adjusted every time there is a thunder track played. So it is a random number that drives the volume. So quiet to really loud. That volume determines how bright the flashes are, and it also determines the duration of time between the flashing and the sound playing. So those are all interconnected. So the quieter the sound, the random sound that we determine, the volume, it will be a dimmer flash, and it will be a longer time from flash to sound, as if it is a distant, lower energy sort of strike. If it's a very high volume, hits 29, 30, 30's max, it's full intensity on the LEDs and it's almost instantaneous on the sound playback. So it's like that sucker's right on top of you. So that brings hopefully a little bit more realism and some variety to it. So the basic thing is generate the random volume, set the brightness, set the delay, then go and randomly flicker and flash the LEDs in strange and mysterious ways. There's just a crap ton of random numbers in there that help change the color and the duration, so the flickers are never consistent or the same number. It's anywhere from like 5 to 15 flashes, and the durations are all randomized. So there's a lot of that going on. Once that happens and it's done flickering and flashing, it will pause for some duration of time based on the random volume number. It'll play the audio track. All of this is geared so that the time it takes to do this whole thing is not any shorter than the longest track. So I am not keeping track of how long or whether or not the audio file is playing. I just make sure that everything is taking long enough so that it will never overlap and cut a track short. As simple as that. We could actually do stuff a little bit more sophisticated by wiring up one more pin. This pin right here actually will go high or low depending on whether or not a track is playing. And I could bring that into D5 and I could start to listen to see if that pin is high or low. And I could actually know if a track is playing or not. So that's something we could do, but we're keeping it simple. We got enough going on with all the random stuff. Once the track is done playing, it pauses for another random duration. So what we're able to do is we're able to really dial up or dial down sort of the intensity by changing that number. A longer duration will mean the time between this whole cycle takes more time. And so the storm feels less aggressive. I can dial it down, dial it to a really short duration so that it's basically flash, pause, sound, quick pause, flash, pause, right? And it can be much quicker, much higher sequencing there. And if you wanted a really aggressive sort of effect, you could have these things really just running through as quickly as you could. That's kind of it. There's a lot of code in there that randomizes a bunch of stuff. But the randomizing really just helps it from looking monotonous or feeling monotonous. And it gets a lot of mileage out of the 8 tracks. And it allows us to vary the intensity of the sound of the tracks, the intensity of the light, and make it feel a little bit more organic, which is the name of the game, which is one of the things Gene was looking for. And so with that, we're going to wrap this up. I want to say, first of all, thanks, Gene. Thank you for challenging me to do this. It took me a minute to get to the project. I had to sort of ponder it for a while. I had to do some desoldering. Sorry about that. But I think we got what we were going for. And so I'll be reaching out to you and we'll be chatting. But for those of you who have staged through to the bitter end of the lightning, the Uber lightning machine, thank you. There's a lot you could do with this. This doesn't need to just be lightning. I could see a lot of applications with battle scenes or battle dioramas, terrain, things like that. Anything where you need to tie light and sound together, or you actually get rid of the whole light thing and you just need to be able to control sound with your microcontroller. Lots of goodness here and lots of opportunity. I know that I've been doing a lot of electronic stuff and I semi-apologize for that. But for those of you who have not thought about adding electronics or what you could bring to your gaming, to your diorama, to your terrain table, I hope this is piquing your interest in what the art of the possible is. Arduino is an easy language. This is basic soldering. There's a lot of stuff out there, a lot of tutorials. I'm going to link to all sorts of stuff in the description that'll get you going and make your lives easier. And so this is very, very approachable, especially when you have people walking you through it and getting you through to the other end. I did not make all of this up, and like I said, I did a lot of searching to find the right approach, and I think we got some good results. So, enough chit chat. Thank you so much for watching. If this was helpful, interesting, engaging, hit the like button, subscribe to the channel, all of that good stuff. Follow me on Instagram. I swear, I promise I'm gonna make some stuff that doesn't involve electricity much in the future and get that posted. And we'll see you back real soon for another random making encounter. Thanks again for watching.